Welcome back to our Global Crop Production Virtual Conference, a presentation of Farming Smarter, with appreciation to our smart partners like Down to Earth Labs and FMC. Well, our first after lunch stop helps us appreciate the great work being done close to home as we bring in the legendary Ken Coles from Farming Smarter. Of course, Ken is a passionate agri-innovator, and that started right in his early days on summers at his grandparents' farm just north of Coaldale, Alberta. He's proud to have bought that farm, and that's where he and his wife and 3 boys are actively farming. And that keeps Ken busy as he continues experiments there with things like subsurface drip irrigation and a new venture with 10 acres of willows. Now, Ken's 25-year career has taken him through a number of agriculture research and extension organizations, but his drive and dedication have really helped bring Farming Smarter into a world-class agriculture innovation hub. Now, Ken really believes these regionally focused groups are essential to ensure farms remain competitive and resilient. In his current Nuffield project, he'll be studying similar organizations around the world so he can share the best organizational practices and approaches with Canadian groups. So, of course, Farming Smarter exists to drive innovation at the farm level. But what does this mean? Let's hear from Ken as he shares with us work on some interesting projects like night spraying, recovering from hail, and even hemp agronomy.
Hello, everybody. My name is Ken Coles. I'm the Executive Director of Farming Smarter, and I'm pleased to be presenting to you my topic of farm-focused agricultural innovation. As part of this, I wanted to make note of all of my pretentious letters here, but of recent, I'm very proud to announce that I'm a 2022 Nuffield Scholar. So forgive me for choosing COVID pandemic to tour the world. Not the smartest of guys, but we learn through our mistakes. But as part of this topic, the reason I bring it up is I'm so interested in this topic of organizations focused on innovation and agriculture that that's going to be my topic of study. I'm going to tour the world looking for organizations that are helping farmers develop agriculture innovation. So if any of you out there have any ideas of great places to see, I'd love to hear. You can send me an email or even just post it in the chat. So I look forward to hearing from you. So when we talk about innovation, what does that really mean? And I can't even get my slides to work. There we go. So the context of what does it mean? Well, this is actually a picture of my great grandparents who immigrated from the Ukraine. And here they are on their farm around 1925. And they've got what it looks like a beautiful wheat crop. So what does innovation mean to them? And I think that it's quite interesting. They look like pretty tough folks. And see, I remember this is my Baba. She was this tiny little lady, but when I see her in this context and try to see the world through her eyes in 1925, trying to establish a new farm on the prairies, it kind of gives you another perspective. So for them, my grandpa actually first started out working for the CPR and for the coal mines. And he was even one of the fellows that worked on the high level train bridge. But, one of his first innovations in agriculture was this team of horses. And from what I hear, this was, the most important part of the farm. And he formed a very solid relationship with these animals and they helped him cultivate and seed and harvest. And that was sort of their main tool for making a living on this prairie. So since it was a dry, semi-arid area, one of the innovations for them was simply water. Like, can you imagine how important it would be to have a dugout when you're 6 miles from the river or 6 miles to the nearest water? So they actually used a little implement and they slowly dug a dugout using a team of horses. So, that now they have water to feed, to water the garden and so on. And what an amazing innovation something as simple as a dugout would be for them. So here they are, adopting a new piece of equipment. And I wish I really had this old John Deere tractor. And you can see my Guido has a bit of a tiny smile on his face. And I think Baba, she's like, oh boy, what the heck are we getting ourselves into? This is a big change, probably a big investment. And, is it going to work for us? And interestingly enough, I actually still have this cultivator here in the background in my yard. That's the yard art for us. Here's actually my grandpa now is in here, and they've got their big yield harvest in the truck here, but this is how they unloaded it. They did it by hand. So imagine what an auger would have done for them in those days. But I can tell you they look pretty slim and trim, and so here we fix all of these problems with technology, but now we have to go to the gym to stay fit. So this one is actually my grandpa too, and it's now we're into rubber tractors, and it may maybe the swather was quite innovative. What was most innovative about this picture was that it was more of a social innovation. It wasn't all about the technology. It was honestly, grandpa couldn't stand farming with his brother. They fought all the time, and they never got along. So in this sense, he bought a new piece of land. He bought some of his own equipment, and they branched out, and that's how things go. And it's always interesting to look at different aspects of innovation. It's not always technology. It's not always agronomy. Sometimes there's something simple as wanting to build something on your own, or decide who you want to work with. So what does innovation mean to all of you? And that's something I'd like you to think about throughout this presentation. I'm going to highlight what it means to us at Farming Smarter and some of the projects that we've worked on. So to start, I think a lot of times people get the terms research and innovation confused. So I did search different definitions. I came across one from the Alberta government that I thought was pretty good. So for research, they say the process of systemic investigation used to advance knowledge. Research explores the world in which we live, discovers new ideas, and is the foundation to address long-term challenges. Applied research focuses on exploring the application of ideas directed primarily towards a specific aim or objective. I'd like to throw in another one called adaptive research that we often forget about and the importance of it. So for innovation, they actually say that it's a process. So the process by which ideas are implemented and executed and value is added. And I think that's the key thing is you can have lots of great innovative ideas. If they're not applied and they don't add value, then is it really innovation? So in the form of new and improved products, services, and approaches, it may draw on research and development and may involve commercialization. Innovation includes new technology, design, business and social models, and mechanisms of service delivery. So quite a distinction when you see it on paper like that. And again, I think innovation can take a lot of different forms depending on your perspective and your angle of view there. Another component to this is I like to think of things as an agricultural system, an innovation system in this case. So for us at the core is the farmers. And to support the farmers, we have a research system. And also we need to have an educational system so that the younger generations can learn the basics and be able to, again, help support. So they also want to be connected to the research world and understand its importance. We also have an extension system. So that's sort of not just the knowledge transfer, but the people component and the cheerleaders and the ones that look at the big ideas and connect the dots. And then all of that is an agricultural knowledge system. So I just kind of like this model because it kind of puts it all into perspective. And then again, supporting and partnering and benefiting from the farmers within this system is exporters and processors and input suppliers and so on and so on. And all of this is sort of guided and governed through policy and regulatory framework. So if we think about an agricultural system, is it working? Are there parts of the system that are functioning and other parts that aren't? So it's kind of a holistic look at this idea of innovation. One of the things that we did at Farming Smarter a couple of years back was, again, we're trying to reinvent ourselves as a nonprofit organization and ensure that we're working in areas that we should be and not competing with others, because there's really not a lot of resources left within this realm. It seems support for public interest and public research has been diminishing. So where's our fit within this whole system? 83% of people said they want us to be working on practical and adaptive research. So something that matters to the farmer, something that the farmer can use and employ. A high number supported our efforts in on-farm research. So working within the farm and looking at, using precision tools and actual field settings to do research. interested in innovative practices and technologies, lower support for sort of industry funding, but interestingly enough, only 30% now for peer-reviewed public research. And so that's sort of the role we would say here for agriculture and agri-food Canada and for universities. So it doesn't mean that we can't be involved in peer-reviewed, but in the long and the short of it is that the clients that we're working for really are less concerned about published peer-reviewed as they are, does it work? Is it something usable on my farm? In the types of research, lots of interest in soils and nutrients. So 80% there, 67% for cropping systems, 65 for agronomy, and then lower numbers for equipment technology, crop protection, novel crops, and precision agriculture. It's actually surprisingly low interest in precision ag and digital ag. So I'm going to go through some innovations at Farming Smarter, and I just wanted to have a video playing in the background here. This was actually 2019, pre-COVID, so there's actually people without masks in it. But we're involved in all kinds of things. Here's one where we built a pesticide rinsate biobed, and this is based on research from around the world. This one was a crazy innovative idea, and then this is where we were actually training a dog to sniff out clubroot. And we actually were successful at doing that, although the innovation isn't complete because we're not really actively using it. We haven't found value for this approach. We do work in novel crops. So this is a shot of hemp. We've been working on developing industrial hemp as a new product. We have exchange students from France, and that may seem inconsequential, but part of their degree program is to send people around the world to get an agricultural experience. In doing so, we're learning from them. We do work in precision planters, and this is a shot of looking at canola seeded with a planter on narrow rows. Here we're back to our hemp research, and that's ongoing. So that as we continue to develop, we're very excited. I think at the end of my career, I would be very excited to see hemp as a major industry in Western Canada. Louis Barta manages our field tested program, and within that, he's always looking for different types of trials to support agriculture. And Trevor here is our contract research manager. We work with lots of different companies and doing contract research for them. I think what's good for farmers is that they get local data supplied, and we also form relationships with all of the industry innovations and can incorporate that into our programs. Sometimes we do off the wall type stuff, like looking at pollinator blends and trying to deal with marginal lands and have an opportunity to work in different areas. We do lots of efforts in communicating, and we invite lots of farmers and researchers to field tours. And we try to share everything that we learn, but really what's important about this part is that we learn what's important to them. And sometimes we'll develop new projects based on these extension events. So it's really our major needs assessment tool. We also share everything with the public. We usually have an open farm day where we invite folks from the public to learn and see what we're working on. We have a good relationship with our local college. We have students come out every year to learn different aspects of agriculture and research and get some hands-on experience. We also do lots of advocacy. So here we are touring some MLAs and the provincial ag minister and all kinds of different things. Also, we're innovating on how we share information, and we try new things. They don't always work out, but no matter what we do, we continue to try to push the envelope on new ways of everything that we do. And that means research, the social side of things, how we communicate. So long and the short of it is that we've got a pretty active all-around group where we end up becoming this hub of information, and we like to share everything that we're doing so that public good piece is there. And really it's about a community and a culture of innovation. So to highlight some of the projects where we're quite proud of our efforts, I'm going to go through a number of what I'd say are more impactful and interesting trials. So this was one of the first ones I worked on when I started working here, before it was Farming Smarter even. And back then, everybody was adopting auto steer guidance, and they were driving their tractors throughout the night. And so a lot of them, because it's so windy here in Southern Alberta, were even spraying at night, and none of the herbicides or fungicides were really registered when applied at night. So we wanted to test a number of different herbicides and see if spraying at night actually, either caused a reduced efficacy or if there's benefit. And there's also concerns over things like inversion. So that's kind of a scary thought of having your pesticides drift off target. So this one picture here is actually of a field school that we set up after 4 or 5 years of this work, and it kind of captures just about everything in it. So there's 2 different days here just to get some different weather, and then we sprayed at all different times, 5 a.m., 7, 9 a.m., and you can see a total difference in control. Here's the check that's untreated, and look at this at 11 o'clock here on this day. So whatever the weather conditions were there, 11 o'clock and 8 o'clock, we had almost no efficacy. So that's pretty dramatic when you come over here. So what happened there on that day is it was a hot day, and the plants or the weeds were under stress. And when they are under stress, they actually stop growing, and everything shuts down, and they're not uptaking herbicides. So, what an amazing dramatic effect to see. So, lots of times farmers would be spraying, and one field they'd have great control, and the next field they wouldn't. I think a lot of times it had to do with this time of day. So when we're dealing with glyphosate tolerant weeds and so on, this is now a tool people can think about. What are the impacts of the daily cycles and weather and the stresses on the weeds? When we're looking at Liberty here, we actually split this up into half with a fine nozzle and half with a coarse nozzle. And you can see at 5 a.m., it didn't work too well with the coarse nozzle, but with the fine, it wasn't bad. And then it got better throughout the early morning and afternoon, and then it actually started to go downhill later in the afternoon. And then again, back at 11 here, we're not doing so great. So very practical tool, and just an awareness for farmers to consider when they're going out and doing their spraying. Recovering from hail. This was also an interesting project, and this was really farmers coming to us and saying, "Hey, Ken, there are these companies that have all of these products that are having claims of helping recover from hail damage, and I've tried studying them on farm, but there's so much variability, it's tough to do." And when we looked at this in 2018 and 2019, pretty amazing amount of lost revenue from hail in Alberta. We're actually probably the hail capital of North America, right next to the Rocky Mountains, and we have a lot of pretty wild weather. So there's $300 million payouts just from AFSC alone in 2019. So pretty significant impact. And if you can imagine, of all those acres, and the desire to rescue them in some regards would be pretty strong. So the innovative part was that we designed a hail machine so that we could study this. And it's quite a simple design. It's just like an old minesweeper with an orbit motor and rotating chains. And we actually brought in the AFSC hail adjusters to look at this and rate it. And they were quite impressed with how it mimicked hail. So now we were able to control studies and test things at different timings, at different levels. We just simply went back and forth over it a number of times to reach different damage levels. And then we sprayed these products on after a day or two after, mimicking the farmer's approach. Of course, for us, you don't get the rainfall along with that, but in Lethbridge here, we were able to irrigate. So trying our best to simulate the environment. So now we have 27 treatments that we put together. We did this in field peas and wheat and dry beans, and we had 3 timings and different damage levels. And then we just went, and looked for products. We weren't picking on anybody. We just found products that had hail claims. So in field peas, we ended up spraying ATP relief plus boron, and we also did a fungicide. There's lots of anecdotal evidence of these strobilurin fungicides helping the peas recover, and then a check. For wheat, we did the Alpine 22 and boron. Procero fungicides, we chose fungicides that would have an impact on Fusarium head blight as well, because that's a potential vector. And then we had checks. Dry beans, we did Omex P3 and a parasol bactericide and a check. And the long and the short of it is we were successful at damaging our yield with our machine. Surprisingly, not as much as an effect or difference between the light damage and the heavy damage. Really what mattered was the stage at the crop that we did the damage. So we did three different stages, sort of early, mid, and late stage hail as well. On the wheat side of things, the crop itself is more resilient to hail damage, so not as big of a loss in yield. And again, not a huge separation between the lighter and the heavy damage. In our case, the light damage was about 33% that we were shooting for, and heavy was 66% defoliation. So the long and the short of it is none of these products actually were successful in recovering the crop from yield. It's just one of those things you're probably better off spending more money on insurance or actually taking that crop out of production and reseeding to a forage or a short season crop. And that's probably one of the next things that we'd like to study within that hail project. So I mentioned hemp earlier, and such an amazing crop. It's an opportunity for various different types of markets. What's interesting is hemp is one of the oldest crops that we've ever grown, yet we're still now considering it an innovation. And the innovation part is actually how we use it. So it has a long history of supporting civilization, but now we are here back looking at it for food, feed, fiber, and now fractions. And the fraction piece is really a newer part to it, and that's looking at the cannabidiols like CBD and CBG, and there's all sorts of different things being studied in medical sciences and health benefits and so on. So it's such a neat crop, and it grows in so many different conditions, but there's actually a lot of need for new knowledge. How do we grow a crop for grain versus for fiber and so on? And Mike and the crew up, like, this is a silage, or sorry, more of a biomass crop, but the biomass potential for these crops is just amazing. Here's Lewis on his knees showing how tall one is, but look, here's one me that's about 14 feet tall, this hemp. That's a Salacia grown under irrigation. So very amazing crop, lots of different uses. Mike put this picture to slide together just to show how amazingly different the seed and head production of the hemp varies with both seeding rate and date. Just something as simple as that really affects how the plant grows. So understanding the agronomy to growing hemp for different uses is quite important. So some of the results that we've seen, and interestingly, there was always a lot of effort looked into the fact that hemp didn't really have a yield penalty by seeding it late. And that's true for the grain side of things. But when we're looking at biomass, and Salacia here is the important one, as we seed earlier, we're definitely seeing an increased biomass production. So if we're targeting biomass or fiber industries, then seeding hemp early is important, and a significantly reduced amount at a later seeding date. When we're looking at plant density, we're noticing also that with that later seeding date, we're often having a hard time getting the plant established. Whereas when we're looking at different seeding rates, not as huge a difference between the timings, the early and normal timing. So, but when we look at grain yield, it does actually work out. And this trial was done across Alberta in Lethbridge and Vegreville and up in the Peace. And we're not seeing a tremendous reduction in grain yield. So when we're looking at different seeding dates, which is quite interesting. So moving on to another project, and this is one where we've been adapting precision vacuum planters into small grain crops. So this is an advanced seeding system, but not to us, but it's really an old approach for the corn and soybean folks. So in southern Alberta, we're using them for dry beans and for sugar beets. So some farmers have started using them for canola seed, and in particular seed production. So the difference between a regular drill and this is that we have a plate, and each plate individualizes each seed. So we've got this perfect placement of seed. They also have a parallel linkage and do a really good job of depth control, but often seeded on quite wide rows compared to what we found best in our small grain systems in Western Canada. So we did a study looking at canola and different row spacings compared to an air drill. And this picture really captures the value of the planter. And as we've moved the planter to a 12-inch row spacing, you can see we've got canopy closure at the very low seeding rate. So 20 seeds per meter squared, depending on the type of seed, this is less than a pound per acre. Whereas our air drill, you can see it's very sporadic and we've got holes and we don't get good canopy closure probably till we're between the 60 and 80 seeds per meter squared, or probably around 4 pounds per acre. So when you look at that, and here in our short growing seasons, what we want to do is get full canopy closure by the June solstice. So that's where we have the longest daylight hours. We're capturing as much solar energy as possible, because that's really what this is little solar panels in the field. Here's a shot of the plots where you can see at one seeding rate the difference between full canopy closure. This wider row, while the plants look big and branchy, there's still gaps in between here. So we'll just think about that when we look at the results here. Overall, we actually saw no yield reduction compared to the traditional air drill, but we did see quite a significant yield advantage on our irrigated sites, or high yielding production. So here, almost a 10% yield bump under irrigation. But we also saw a yield reduction with that wider row, which is interesting because that's what a lot of farmers are still planting the canola on, is these wide rows. Other parts of the world are seeing no yield reduction, but I think because of our growing season, that wide row isn't just getting canopy closure enough to maximize our solar intercept there. So we also then thought, well, if we're going to look at canola, let's look at some other crops. So we wanted to try it out on pulse crops. Again, this is on narrow row and dry land scenarios. We did chickpeas, lentils, faba beans, field peas, and soybeans. And so far we've done 2 years of study on this, but we'll have 12 site years when we're complete. And again, comparing to an air drill, and just did 2 seeding rates, half cut seeding rate and then a full seeding rate, just to see, a first look at it. It was quite interesting. Some of the crops we saw a huge advantage. So this is our percent emergence on chickpeas, a rather large seed, significantly better emergence. So 80% versus about 50%. On faba beans, we saw a huge advantage. And also we saw a huge advantage with peas, up to around 70% versus, just better than maybe 55%. No difference on lentils and soybeans. And lentils are kind of an odd shaped seed. So we're not sure if there's a big advantage. And then when we look at some pictures, you can just see, the difference. So with the faba beans, just big gaps between it, whereas with the precision planter, it's just doing a good job of placing each seed. It's flowing nicely. It's got good seed to soil contact with that seed firmer. Lentils, even the same thing. So a low seeding rate, we do get these gaps, not near as bad. It looks like a pretty decent coverage here. And it just, always looks perfect with that precision planter. When we looked at the yield results, we're seeing a big yield advantage on the chickpeas. We saw 33% yield advantage. Of course, the last number of years, we've had some pretty bad drought. So I'm not sure, if the results will continue. We need to have a number of site years to make sure we're looking at different production environments. Surprisingly, though, we almost statistically saw 11% yield advantage with lentils, even though we didn't see that advantage with the emergence, which is interesting. And we saw an 8% yield bump, statistically significant for peas, no difference on the soybeans. So we also tried this on irrigated durum. So we had a farmer who said, we haven't been able to increase our durum yields for many years. So we thought we would take a rather intensive approach, looking at this precision planter versus an air drill, a low and a high seeding rate, a normal fertility versus a max fertility. And then we'd also included growth regulators and fungicides. So kind of the kitchen sink approach to this. And interestingly, after 2 years of study now, we've seen on average a 5 bushel increase with the use of precision planters. And of course it varies by location and by environment. And I think soil conditions and timeliness of rains after seeding all make a big difference in these types of scenario. But 4 out of the 6 site years we did see an effect. In fact, in 1 year there was actually a decrease. So I think there are soil conditions that would benefit the air drill over the planter, and we have come across that from time to time. They're not really fully adapted for a zero tillage system, and I think that's an area that we need to do some work in. So another, again, an old practice in another area, but a new practice for us is the use of strip tillage. So we've actually created a narrow row strip tillage. We simply made the strip tillage machine narrower, and we're doing it on a narrower row spacing as well. And we're testing it out on corn and now canola as well. So the idea here is you till ahead of time, and then you've got these followed by the same rows with guidance, and you've got a nicer seed bed to seed into that helps solve that problem. So in our zero tillage scenarios, we're actually, it's a step backwards going back towards tillage. So it's not really all that exciting. But for our irrigated acres, to move towards strip tillage would be of benefit, because we're still doing a lot of tillage. We're seeing a lot of soil erosion, and hoping to study this a little bit further in the future as well. This is another picture that says 1,000 words. So this was on corn, looking at preceding crops. So how do we fit a dryland grain corn into our conventional or our typical rotations? So when we did a conventional system, that means tillage, and then we seeded into a soybean stubble, a wheat stubble, a lentil stubble, a canola stubble, corn stubble, peas, and so on. You can see by the pictures that we've got a beautiful stand, and that tillage just did the trick. Whereas when we're trying to go through corn, that monosem planter, even with residue managers, had a hard time going through it. Looks like we did well after lentils, so low residue crops were great. So this was sort of that need, demonstrated that need for a strip tillage when using these vacuum planters. So we did a study on corn, and we're continuing this study, and this was just one site year of data, but it did prove to be a benefit in this year. So we actually had a statistical effect with over an 11 bushel advantage on the strip till side of things. So, we looked at different seeding dates and different heat unit varieties. And here we also saw a response to a higher heat unit. So when you put all of these different management practices together, often it will result in a pretty significant improvement in production. And we're doing the same thing in canola now. So this was a proof of concept trial where we're doing strip tillage and different seeding rates in canola, and you can see that there's some differences. Even from the swath, I think from last year's residue always causes problems in canola, whereas when you have the strip till, it's pretty solid. Don't see a huge difference here, but on the 20-inch rows, you've got a gap here where there was very little canola growth, whether it was hard time getting through that straw residue or there was frost damage. And then on the strip till side of things, you can see that sort of swath effect is gone. So briefly into the field tested program, we talked about this before, but part of the value of what we do is to actually take what we're learning in the small plots out to the field, continue to tweak them, continue to do on-farm research. And this serves as also an extension tool as farmers see how these approaches and practices fit on their own farm and their own cropping system. A number of the projects that he's working on currently is looking at a passive spore trap to help determine whether there are pathogens and that we need to be scouting and spraying fungicides. We were mapping glyphosate tolerant kochia and trying to take a patch management approach to dealing with that issue. We're using EM38 for managing and determining real-time moisture. So if you're going to do a split application of fertilizer, that you're basing it on soil moisture. Precision planting canola. So I talked about that project. He's now taking this out to the field and trying to determine the true value of this change in management practices in the field. We're looking at variable rate irrigation, looking at plant growth regulators and seed alfalfa, and flea beetles and neonics. So this was an interesting one I'm going to show you about quickly, just because of his trial data. So the fear was that we were going to lose neonics as a seed treatment, and then flea beetles are becoming a problem. So working with Dr. Hector Carcamo, a cultural approach to dealing with that is simply going to a much higher seeding rate. So even 100 seeds per meter square is pretty high compared to our standards now in seeding canola. But you can see that with an untreated seed, we're getting above our threshold of 20%, 25% feeding damage. And with the foliar application of insecticide, we did get below that threshold. When we jump up to 200 seeds, not really a big difference. We're still going above the threshold, and we're still getting below the threshold when we're spraying a foliar. But with that seed treatment, you can see how well they work. So very low feeding damage and no benefit to the foliar insecticides. Interesting, when you look at the yields, not a huge difference. Of course, There was a yield disadvantage with the untreated seed, but when we moved up to the higher seeding rates, we were actually parallel to the commercial seed. So thankfully, neonics are still in use because I feel it's a lot safer way to have a seed treatment than to actually spray a foliar insecticide. But this is one of those real practical approaches to studying things on the field scale to dealing with real problems. And so if that ever did happen, we've got a solution waiting. Maybe a costly solution, but a solution nonetheless. So too much innovation, that's how we feel often as we're managing over 120 research trials every year and trying to make sense of it and try to add value to these farm productions. So quick little comic break. Here's some Canadian innovation that I thought was a pretty novel. I mean, I suppose you could just get a tractor, but just go on the sled there. And this one I'm not too sure of. I'm actually going to call this regenerative farming 2.0. So now we're really pushing the envelope here. So to end things off, I want to highlight what I feel is our problem right now with agriculture innovation. To be perfectly honest, I feel like the innovation system is somewhat broken and disconnected. First of all, I don't think there's a full appreciation for it. And I think there are certain systems that are not working. If you think back to that system slide, I don't think our extension system is working the way it used to. As we are losing our public service that used to be more involved in agriculture and having that different perspective on the big picture, I think the whole industry has become quite siloed. And there's so many different farming systems, so many different commodities, and it's just really difficult for us to work together as an industry. It's a complex industry, I'll give you that, but we're going to have to rethink how we all work together to maintain our competitiveness on the global scale. And on top of that, we're dealing with massive droughts, massive floodings, all kinds of different big issues that we need to work together on. So I don't believe that government is truly leading this anymore. We used to be spoiled that agriculture was the most important industry. It's no longer the case in the grand scheme of it. I hope that with what we've learned from COVID, there's obvious global logistics issues, food security, and the importance of food has been sort of reinvigorated. So we may see some opportunity to continue our efforts. But it's going to take a lot of work. On the flip side, and I don't mean to be negative on this, but I think sometimes farmers are their own worst enemies. And anybody who's worked in the industry long enough with farmers understands this, and farmers themselves probably understand this. Part of it is that we're so focused on our own operations that we're trying to make ends meet, and we're trying to innovate and be successful and drive for logistical efficiencies that we sometimes forget to step back and look at this big picture. And we're so good at what we do. The competitive piece is important, but this is something where I think we all have to work collectively on the social innovation side of things so that we can still maintain our effectiveness and support moving forward. So we're interested as a potential solution. Our federal government is launching what's called a living lab, and we're currently in the process of applying for one of these labs for Southern Alberta. And I think they're a great concept. It focuses on farmers' needs first. While our government is trying to meet its climate change commitments on carbon sequestrations, they recognize that there's no point in research or innovation if it's not going to add value for farmers, and farmers aren't going to adopt practices. So we think agriculture is a solution, but we have to focus on the farmers' needs first. There's broad and diverse partnerships. So we're going to work with all kinds of different partners. We always have, but this is forcing us to work even in broader scopes with different types of people that we haven't in the past. And in the end, as long as you invest in the relationships, I believe that it's going to help solve some problems. And it's focused on testing in real life contests. So just like I've explained in this presentation, we have to be out in the real world. We have to be looking at the whole picture, the logistics, the manpower issues, the social issues, in order to incur practice change. So they have three things of looking at this in a design thinking concept. And I like this. We look at the feasibility. So for us, this is agronomy. And how to, and logistics. But we also look at the economic components and the return on investment. They don't always make sense, but we also have to look at the human element. Is it simple? Does it solve problems? And is it something we want to do? And then whatever happens in the intersect is, in theory, what's going to invoke practice change. It's also meant to be a cyclical, iterative approach that sort of continues through each section. So from conception, prototyping, to development, and then ultimately adoption. And this doesn't really follow the traditional scientific approach. We tend to look at things in a longer term concept. So let's create our protocol for a 3-year study and don't deviate. Whereas this might be, we need to adapt on a yearly or even faster. So more like a business would iterate on a technology development side. So I want to end off with our brand promise, because this has been important for us as an organization. We're not just an applied research group, we're an innovation hub. And what we really are here for is to build and inspire a culture of innovation. So our brand promise: farming smarter exists to drive agriculture innovation at the farm level. We attract a community of passionate innovators and provide agronomic testing, scientific knowledge, and the right connections for them to succeed. Innovation drives us and not profit. This makes us a trusted source for regional adaptation of profitable and resilient crops and cropping systems and agronomic practices. Farming Smarter instills a culture of innovation and takes a bottom-up approach that is gritty, practical, and achievable. As a flexible organization, we take chances, break the rules, and encourage failure so we can learn. We adapt and excel at innovation, development, and adoption. This is crucial to keep farmers competitive and viable in a complex and dynamic environment. Innovators can rest easy knowing we scan the world for new and old ideas that may apply locally. When they turn to us, they are confident our information is grounded and relevant. And we love agriculture and offer our community informative, safe, and enjoyable experiences. They feel part of a diverse community who enjoy learning, networking, bouncing ideas off each other. Innovation is hard and about long-term results. We invite anyone interested in agricultural innovation to work with us, and together we can change the way people farm. So that's what's exciting about today's conference, and being able to hear from people around the world is the opportunity to see common issues, common challenges, but also to work together towards common solutions. And this is a quick video that I filmed this last summer, and for me, this is when it all hits home. And I'll just play it for you.
So last year I attended one of the field schools at Farming Smarter, and I saw how they were doing some of their pulses with a vacuum planter. We have tried in the past with a disc drill to plant this crop with a lot of struggles, and I thought, well, they've done it with a vacuum planter, I want to try that too. So I took the idea back to our farm, and I've got one guy here who's very enthusiastic to try my ideas. And so we have a 22-inch vacuum planter, and so we decided once we came out to the field that 22 inches was too wide, and so we double seeded, and so we've got 11-inch seeded faba beans out here.
So I assume you have a pretty accurate guidance system on your equipment to do that, or?
Yeah, we've got, this was seeded with a Fendt tractor, and it's got whatever the GPS tracking is on the fence. So
great.
Yeah.
So are you happy with how it looks so far?
Yeah, really happy. The crop's looking great. It's loving the pivot going round and round. In this heat, the last week, it's really taken off. You can see there's a few flowers.
So I thought that was great. We haven't even learned whether the practice works or not, and farmers are out there trying it on their own. And I think that's the real power of bringing people together. And this is my final slide. And really what innovation is about people. And if we can share ideas and work together, then I know that we're going to create a fantastic solution for agriculture. We're all so passionate about what we do. And I look forward to working with all of you. So thanks for your time, and I'd be happy to answer any questions.
Ken, it looks like the folks are starting to come in because everyone's eager to talk with you. So many good informative things that will spark reaction from your challenging conclusions to your interesting too much innovation pictures. Those caught a lot of attention too. Those that just shows how creative you are. I don't know where you found those, but did you type in innovation in Google?
Oh, crazy. Google will get you anything you want. You know, we did just do a number of sessions where we were talking about innovation with farmers, and we did hear, you know, overwhelmingly in many regards that you get innovation overload. And I think too often it's sort of almost Hollywood styled innovation, you know, smart this and smart that, and everything's shiny and fancy and technologically advanced, but it really has to be practical. It has to be easy to use, and I think that's one of the big challenges we're faced in agriculture. There's some folks that are just sitting around waiting for the right time to jump in with certain aspects of it. But you know, when you look at that sort of desirability piece, sometimes the technology advancements are just too much to handle.
Yeah, good perspective with your great grandparents. The fact that they just could get water from a dugout,
Yeah.
which was innovative at its time, but yeah, simple. Looks like we got most people. Maybe just as we're waiting for questions, again, everyone, if you're just coming in and you've got a question for Ken about any of those particular research or big picture research or innovation, be sure and type them into the chat, or else raise your hand with the little reactions there, or else just give me a note that says that you're interested in asking a question. But Ken, maybe just to start out, I'm kind of curious about your Nuffield Scholarship. Maybe give us a little background. When do you start it? Tell us a little bit about, if people aren't familiar with Nuffield, you know, what you're going to be doing and how it's all going to fit together.
Sure. Well, I think that was the middle of the summer here when I kind of decided last minute to apply, almost out of frustration, because we've been going through a lot of changes in support for our work in Alberta. You know, that there's been big cuts and creations of new funding agencies, and I'm like, I just don't know what to do next in trying to demonstrate the value of what we do. And so part of it was along that front, is I can't get solutions here, maybe I'm going to tour the world and magically there's going to be some solutions out there. So I was part of another international call where we were talking about it, and they kind of almost said, you know, they encouraged me to apply, but I also noticed that they were also being faced with the exact same problem. So I'm not so sure we're going to find all the right solutions everywhere, but you know, I was just did our orientation in Winnipeg a couple of weeks ago, and it's supposed to start pretty much after this new year. And I'm not sure now with the new Omicron concerns and travel restrictions, it's probably going to wreak havoc on our plan. So I don't really have much planned out yet. Even the topic today with was it Jerry? You know, I'd love to go see what they're doing, because that whole approach, it's really a living lab what they're doing. And I think in France they also have a network of them as well. So that would be kind of a first start. But otherwise, I'm still kind of hoping that I can plan that out down the road. It'll take the next 2 years, and I'm supposed to do 10 weeks of travel over those 2 years. So I've already, you know, been overwhelmed with the honestly the amazingness of the people that I've met within that community, because it's like joining a family. So it's like a lifelong commitment, and I didn't really know what I was getting myself into, but it ties in so nicely to what we're doing here, and I'm starting to look forward to it.
Yeah, I know I've had a chance to interview some of the past recipients, and so many different topics have been studied, and yet there's that common link about wanting to learn more and be innovators really in their fields. So that's kind of cool. All right, now there was a little bit of chatter on the original platform just about whether or not you studied mechanization in that one particular aspect that you you know, highlighted. Do you want to talk about that at all?
Yeah, I think the question was whether we actually looked at mechanical damage to the seed. So one of the concerns with some of our coarse grain pulses is that there's a a physical damage that happens to the seed in going through the air seeder itself, and whereas the precision planters are a lot more gentle in dealing with the seeds individually. There's probably some effect to that, but it wasn't something that we actually studied.
All right, so we are looking for any questions. If there's anybody that has anything they want to ask Ken about some of his work, come on in and put your hand up or pop in with a question. Maybe let's touch base a bit about the hemp. You know, you were almost ahead of the curve in terms of you know, being research focused on hemp, and I know that there are some great hemp operations down there already. What's the latest? Now, it seems to me like you're almost sort of wrapping up that project, and are we starting to see more industry adoption of it yet?
Yeah, well, I think in developing any novel crop, it has its ups and downs, and there was definitely what we were calling a green rush for a while there. And so a lot of farmers were getting into the whole CBD side of things, and there was a whole schwackload of different companies that were sort of startups. And I think we've sort of, some people got bit by it, and there's been, you know, kind of a pullback. So I think anytime there's a new crop that is finding its way into the marketplace, there's going to be ups and downs, and that's what's happened. You know, we have been working on it for over 10 years now, but Jan Selesky's been on it for about 20 or 30 years. So I think it is just one of those things that takes patience. And I think what's new and exciting is I have seen some fiber-based plants starting up in Alberta. We still don't have much yet in southern Alberta. The main market has still been the grain and the healthy, you know, hemp hearts and so on. But as the regulations have changed, that's opened up the opportunity to test some of those medical options with all the cannabidiol. So our program is coming to an end. This would be sort of our agronomy 2.0, and we haven't really touched into the CBD or cannabidiol side of things, but we're going to build this in as we're building this application for the living lab. There's more opportunities even to look at using hemp as a bioproduct. You know, has a really great environmental story to it. So there's a company out of Seattle that we're looking on putting a proposal, and it's all about using hemp for bioplastics, and they're looking to set up shop here in southern Alberta. So I think that's kind of exciting to actually see some more private investment. And it's always chicken and the egg. These companies are afraid that they're not going to get the production out of farmers, and so this is another example of where innovation falters. And you know, are you willing to sign a contract and deliver a certain amount of product? Or, you know, these companies are also looking for commitments as well. So I'm hoping to see that develop, and I think we'll probably get into a little more work looking at the redding side of things, and that whole kind of life cycle piece, and how it can improve on the carbon capture side of things. But otherwise, we're busily working on some new proposals to where to take hemp next.
Cool. And yeah, interesting how maybe there's a role for agencies like a Farming Smarter to be a catalyst in helping get that industry off the ground.
Well, I think that is it. You focus on research, but I think bringing people together to talk about it is an important role. And some people use the term bridger broker, and I think that's a, you know, by having the research, by having the extension, it brings the community together and says, hey, well, I'm working on this, and then, you know, so there's something to that, I think.
Cool. All right. Trudy has asked, have you done any research into other claims of advantages of added micronutrient products like the hail recovery products? Have you expanded beyond? And we know there's some great claims out there by some of the other micronutrients. Have you done work into any of the other claims being made?
No, just the ones that we did present there. And I think there were some micronutrients in some of those products, like boron and things like that. And it's not to say that these products don't work ever. It is possible, you know, given the right circumstances. And I know that some agronomists have seen results. So it's not that. I mean, all we can do is say what we've learned through the study, and within the site years, 9 site years of data over 3 years, we didn't see any measurable effect. So it, like I said, there could be some micro or even small advantages to certain products given the certain circumstances. And so on that, we haven't taken it that. But I think what we learned overall is a lot of times you're better off to cut your losses. And I think because we're insured, that also kind of skews our decision making abilities too. So we feel like there might be a bigger benefit to actually terminating that crop with, say, a certain level of hail damage given the right timing, and just following it up with, a second crop, whether it's a forage or a biomass crop of some sort. But you have all these other things you have to deal with. Lots of times the crop will regrow, and then you'll have half of your grain is green and half of it's ready to harvest, and then you have storage issues. So I think we haven't continued that leg of the hail study, but we're eager to. We've actually been declined on proposals, but I think there's still more to be learned because it's such a huge impact. I mean, there's 300 million plus a year on damages that are sent out in a given year.
Okay. Can you answer this one quickly? Does Farming Smarter do any research in Saskatchewan?
We don't have any of our active sites, but we'll sometimes collaborate with different researchers or different groups within Saskatchewan. So a good example is we work with Dr. Andy Kuchar from the University of Saskatoon on a Western Canadian Fusarium head blight project. So we collaborate on a Western Canadian scale, but we focus in our efforts in Southern Alberta.
Great. Well, thank you very much, Ken, for that thought-provoking and extensive presentation.